So we are using the Sentinel 1 data for finding the displacement. This is a DINSAR technique. We are using ESA snap software. So this is generally used for processing the Sentinel data. So this is the whole interface of the data. In this, when you are selecting the data for processing, you need to make sure that the data is on the same swath and it contains almost the same parameters, like it belongs to the same area of acquisition. See here, my data is from August and September. Both the data are on the same location and are on the same swath. So first we need to apply the Sentinel top split. This is to extract the data from the main data. That means you have a big data of several kilometers, and you will be disconnecting or extracting the data from that particular field or area into a small required area. So right now I am selecting the IW2, and then I am selecting the 2 to 3 bands, and then once it is done, you can see the smaller area is separated from the larger area. Once this is done, you can apply the same correction or the split to the next data also, so that both of them lie in the same place and both of them have the same area of coverage and both of them comes in the same position. So the processing depends on the speed of your system also. So before installing the snap and doing the processing, you can just go for the specifications and find which specifications are best for your PC or laptop to process the data. So the processing is done for the first image. You can see the red box inside the white box, which means the data from the larger area has been split into small part, and it is covering my study area. So I am doing the same split for the second data also, as they both belong to the same swath. The bands and the polarization and subswath will be the same. So you can just run and then it will be done. So this is how both the data get split, and you can see the two data which are split as come to one place out of the box. So I am deleting the first data and then I am applying the orbit file. This orbit file will help in better geocoding of the data. So we just clicked on it, and orbit is applied to first data, and the same way we apply the orbit to the second data also. And you make sure you select do not fail when the orbit is not found. So now I am going for the back-geocoding. Back-geocoding means we are joining both the data into a single data. So I am selecting the nearest neighbor, and then I'm removing all the names because I don't want to make the unwrapping phase complicated. So I'm just giving a very small name with August and September, and then I click on the run. So this geocoding will also take some time. Now you can see the both the files are joined into a single file. So you can delete the close the two products on the top, and now we'll be working with this joined data. So we go for the interferogram formation, and in the interferogram we'll be subtracting the topographic phase, the SRTM3 set. Then we'll get an interferogram. So you should be careful while following each and every step. So the interferogram formation is done now. You can close this, and then next step we will be going for the deburst. So we go for the Sentinel deburst and then select the VV because we are looking for the displacement vertical movement. So we select the VV, vertical, and then click on run. Once this is done, we need to go for the next step. So in the next step, we need to go for the subset. That means we need to cut our area little more so that we can get better data and the processing will be fast. So I'm doing the split again. In this I have selected my area of interest from the earlier data, so I can make the processing even fast. So I just have to go for the multi-look ones and then select the interferograms and the coherence and then run once. This is done. If you want, you can keep the data on the top as it is, or you can just delete them, and then we go for the next step of filtering in the Goldstein phase filtering. In that we will be going for the processing parameters and then click run. So this will remove any kind of noise. Once this is done, we can close the other data, and just leave the filtered data, and then we will be exporting it is a snap export. So we just give the destination to where the data has to be exported. I am adding that to the same location where my raw data is. I'm giving the name as export and then save, and then changing the values of the pixel and tile column to 2020 and the processing as 8, and then run. Once this is done, we have to go for the unwrapping phase. In the same interferogram, we go for the unwrapping and snappy unwrap. In this, you have to select the snap phase image and then give the destination name. So you can directly keep the destination name as the export file in the data folder. And then we start. This will take some time. So the processing is done. Now we can click OK and then close this. If you want, you can keep, or you can close this output data and no need to save that. Now we are going for the snappy import. In this we'll go for the radar again, and then we click on the snappy import to import the unwrapped phase. So in this you will be using the first filter data as read one phase, and then you saw here the image from the unwrapped phase. We have to go for the unwrapped phase read 2 and then select the unwrapped snapview HDR file, and then click do not, and then give the name as unwrapped just for the identification, because you already have the existing file name as FLT. So we give this as an unwrapped name. These are the final steps in getting the DINSAR data. So give this as unwrapped name, and I'm changing the destination to the location where the data is being saved, and I click on the run option, just cross-checking all the required files, and then I click on this do not use wrapped interferogram in the target products, and right now, and that is done. Now we have to change this unwrapped phase to a displacement. So we go for the radar interferometric, and then in this we'll see phase to displacement option. So we are converting the phase into the displacement, and then you click run. After this we need to do the terrain correction, so that whatever the data you get out will be again corrected according to the projection of the given coordinate system. So we click on the run option, and this will give you the final output displacement map of the total selected data, and I got my required output. So I can just close this one, and if I open the particular data field, so once I open the displacement map, you can see the total image of the displacement area. So if you want to add any kind of pins which you want to do the study, then you can simply go for importing the pins from here, and then I have some pins, so I'm just adding them, and those pins will be placed over the study area, and then you can copy the information from them. Let's select, and then you can do that. If you want to save the data directly to Google Earth, you can go for the export, and we ask KMZ KML, and then you can save it like that. If you want data without any pins, you can close the pins and then also export data as KMZ format. So once the export is done, we can open the Google Earth file and you can see the final output. So here, if you see any kind of negative values, then it indicates there is a substance going on. Right now we see all the positive values, so you have to compare more.